All right, let's go ahead and get started with today's seminar covering document understanding. First off, I want to thank everyone for taking time out of their busy day today to attend today's session. Also, I want to thank everyone at Ashling Partners and UiPath for making the event possible today. My name is Mike Bork, and I am the growth leader for the South Central region here at Ashling Partners. It is always great to present the information and foster a sense of community. Thought leadership is always something we can give back to the community, and only positive results can come back from this information. So a little information for those who are unfamiliar with Ashling Partners. We're a global diamond partner of UiPath, and we were recently recognized as Partner of the Year in 2020 by UiPath. We have two incredibly talented presenters from Ashling Partners today. Zach Roy, who is the Director of Intelligent Data Capture and Machine Learning for Ashling Partners, and David Kroll, who is a Lead Solutions Engineer at Ashling Partners. He's been automating business processes for over 13 years and has worked across IT in both a solution architecture and lead development role. David will be leading our demonstration today, showcasing the art of the possible around intelligent document automation. For today's agenda, our purpose today will be the first thing we cover: content structure spectrum, purpose of emerging technologies, document automation methodology, use case demonstrations. If you have any questions during the presentation, please put them in the chat section. I know some folks emailed me some questions before the seminar and I have those on hand, but if any come up during the presentation, please put them in the chat and we'll try to get them answered after the presentation. So without hesitation, let's get started. Zach Roy, I'll turn it over to you to start the presentation.
Awesome, thanks, Mike. So the purpose today is to examine the three different structures that data consists of. Data can range from things such as images and video to audio streams and social media posts. Collectively, these types of data can account for roughly 80 to 90% or more of all digital data. And the analogy that we like to use is that of an iceberg. So if most data that we think of is structured or semi-structured data appearing above the water, however, the majority that we do not see is the unstructured data below the water. So let's go ahead and jump right into what these data structures look like. Unstructured data is information that may have similar content, but also have a large number of formats. So emails, resumes, contracts, and lease agreements are all examples of unstructured data. While the purpose of the information is relatively similar, the format of the data could widely vary. Semi-structured data relates to things such as invoices, remittance documents, purchase orders, and bill of ladings. Although the formats may differ, there's some consistency to how the data is formatted. And lastly, we have structured data, which refers to things such as financial reports, federal tax documents, or other forms that are static and don't change much.
Thanks, Zach, for that background. So let's dive into the purpose of emerging technologies. So on the surface, these technologies are going to come at us with a lot of different acronyms, right? OCR, ICR, NLP, RPA, just to name a few. But in reality, we're just trying to extend the ability of what we're able to automate. So that might be retrieving documents and processing them into structured data that we can act upon later. It might be interpreting the data and making sense of it, detecting things like user sentiment, content sensitivity, or even bank fraud. So while there's no master pattern that can be applied to the way you do business, because even the way we do business changes every day, but computers can do their best to keep up by applying deep learning to improve automation accuracy continuously as you iterate through daily operations. And next up, we get into more classic automation techniques, using robots or software applications to connect us to our processes, and even assisting humans as they work, like providing a doctor a list of recommended prescriptions for the diagnosis based off of a trending data set. And lastly, we know that the value of structuring out our automation projects is the ability to capture powerful analytics and visualizations of our processes that we can then use to make better decisions about the way we do business. So you might ask what our method is to all of this madness. And we try to simplify this out in our intelligent automation flywheel. And the flywheel really serves us from multiple angles. It allows us to continuously improve, by improving our algorithms and push the accuracy higher and higher. Imagine a world where you come into the office and the majority of your menial document processing tasks have been simplified into a basic interface that allows you to simply acknowledge whether or not it was read correctly or not, with any low confidence documents being routed to a queue for a team to improve the machine learning model. The big difference with intelligent automation that really separates it from other classic automation techniques is that it gets stronger over time, eventually snowballing into a powerful differentiator for your non-automated competitors. So enough talk around that. Let's dive into some examples of using this technology so that you can see it. The first demo that we're going to look at today is a cash receipt app. And it's more on the AR side of the business, which really allows a team to process digital or handwritten checks faster than ever. Digital is going to get processed automatically. So these are like, created checks by computers, right? While handwritten checks need to be validated because there's going to be a handwriting situation that we have to overcome there. This demonstration is going to use document understanding to determine the type of check. So that's the first decision it makes. It decides whether it's digital or it's handwritten, and it can do that automatically. And then it's going to route it accordingly, and it's going to extract the key fields from the check. And once it's complete, we're going to go ahead and enter all of that into our backend ERP system automatically for further action. So let's see it actually run. All right, so here I've got my two different checks that are located in my input folder. You can see this is the example of the handwritten check. And this next one is a printed check. So you can see like this is one that might come in from like the US Treasury. So we're gonna send both of these checks through our machine learning model and see how it does. And so what's happening here is we're kicking off processes behind the scenes. You would never actually see this interface, but we just want to kind of have some visibility into that it's running. We're going to see that two jobs end up getting created for this. One of them is going to be completed automatically. I believe it's the one at the top. And then the one below it is going to move to suspended state as it waits for a human to evaluate the accuracy of the machine learning model. So here we're getting a task to go in and evaluate that model on the handwritten check. You can see that I'm able to assign that task to myself, and all of the fields it extracted are on the left. And to the left of each field is the percent confidence in its extraction. And you'll note as we go through and confirm the different details, it'll move that to 100% accuracy because a human has confirmed it. But this percent accuracy score can be used for a lot of different things, including task routing and whatnot. In this case, you can see that it kind of screwed up Mary Johnson's last name. It took a best guess at it. It got pretty close, but we need to go in there and fix that. But it only came out with 27% accuracy, and it still took a crack at it, which is kind of cool to see. And then lastly, we're identifying that a signature actually exists. It's not trying to extract the signature because you can imagine that would be very difficult, but it's just trying to identify that a signature is present, which is always an important thing to have on a check. So from here, we're going to go ahead and move forward, and we're going to see that it has extracted the two checks into structured data. So we've taken all of those fields that you saw in the Action Center, and we've mapped it all out into Excel, which you can imagine if you were at like 500 or 1,000 checks, this could be really, really cool. But we've basically got the one check loaded in here right now. And the confidence, you'll see it just has a 1 in it, but it's 100%. It's a percent column, so that's why it's coming up as a 1. But it might be like 0.57 or 0.82 if it was a lower accuracy than that. And so next up, we've got the printed check here, and you can see in this one the confidence score is a little bit lower because it's being automatically processed. So it's not 100% sure, but it's pretty darn sure that this is correct. So that's pretty awesome to kind of see that. Okay, so now we're going to move to the second step, which is actually entering these checks into our system. And to do that, we're actually going to kick off a a robot job to do that. And in the second demo I'm going to show you today, we're going to connect these two together so it all just happens. But in this demo, we've kind of split them up so you can see the robot and what it's doing and when. Before we move forward, though, one thing I did want to point out is that you can see that the ampersand between Henry R. Norm and Leslie E. Platten, it came back as a G, right? And so that's a situation where we might have to take this back to our machine learning model and retrain it to kind of read those Gs, read those ampersands, right? And get that correct value. But that's kind of an example of that retraining loop that you might build in to your process. So here we're going to go ahead and we're going to say, okay, all of our extractions are good. Let's go and enter it into the system. You're going to see that robot run, and hands-free, it's all going to open up the ERP system. In this example, we kind of created a fake ERP system. We didn't want to have to pay all the extra money for a more advanced interface here. But you can see that we can go in and we can specify the different components in the interface. We can tell it what to click on, and we can automatically send in that information into the system. So this is saving a ton of time. It's preventing a lot of potential errors, and just really, really cool to see. So you can see it processed, I believe this was the first check, and then it's going to do the second check next. So we're going to see that happen here. And I think it takes about 10 to 15 seconds to run. Yep, it's already going. There it goes. Types almost as fast as me. Cool. All right. So we can see that's gone ahead and processed successfully. Pretty cool. So behind the scenes, the Cash App uses a trifecta of RPA, document understanding, and Action Center, all for processing these tasks. And these are all provided by a single vendor, which is UiPath, a market leader in this space. So we know that ways to measure ROI around our automations are going to be critical because we have to measure the success of those automations and how much money we're saving, right? So some common success metrics we could pull off this, might include the ability to reduce days sales outstanding, cost per transaction, and so much more. So of course, any automation is going to have considerations. Otherwise, when do we know when to stop automating? Usually it's when decisions become more fluid or really require tasks that we cannot easily program. Anything well-defined is going to be right for automation, including, validating that the document understanding processed the handwritten checks correctly, or maybe even before entering those checks into the ERP system, just to give it that once over, that second glance to make sure before we go in and do anything. So next up, we have an invoice processing demo, and this sits on the AP side of the fence. So here we're receiving all sorts of invoices from the outside requesting that we pay them. And so we need to read those invoices out to a central location quickly and assign confidence measures to the fields we extract. And ideally, this would be something that would be running constantly on our backend environment. RPA actually allows us to schedule those jobs and run them continuously. But for the sake of today's demo, we are going to kick it off manually, but just know that that's something that's super easy to do. But let's take a look at how this works. So invoice processing, is one of our more common client asks, and there's a reason why. And with RPA and document understanding, we can process invoices constantly and much faster than a human ever could. In this example, we've got two invoices. Each one is in a different format. I'm going to head over to Action Center with this invoice. We can kind of evaluate how well the document understanding did. It's going to put that percent score to the left of each field, indicating the confidence. But before I head over there, I just wanted to kind of outline these invoices and show you, what they might look like, what might be within them. We can certainly process the items within an invoice as well. In this example, we're not going to tackle that, but it's definitely something we can handle. So in this case, I'm going to go ahead. I'm going to kick off my orchestration robot. My orchestration robot is going to kick off two sub-processes that are going to loop through this input folder and process those documents. You can see they've already been moved out of the input folder. They're now in the in-process folder. And the power of document understanding is now being applied to these documents. You can kind of see it running there at the bottom. I think I'll bring up a window here on the right. You can see the document understanding process is running. It takes about 30 seconds or so. Zach may correct me on that depending on how long it takes to process, but per document, it's pretty fast. So here's the two tasks that have been assigned for our two documents. You can see in here, I'm able to kind of assign that task to myself walk through the invoice, and we're back where we started, right? Which is around kind of assigning those different details and identifying the fields on the invoice that have been properly or improperly extracted. You can see how easy it is to capture multiple bits of text here. I'm just clicking and dragging and bring it in. It thinks invoice is the business here because it's in the top left, and the machine learning algorithm is kind of taught to look there, but that's fine. We'll go ahead and fix this up. It got the date correctly. The invoice number, we'll just map these, map the PO number. And again, the more iterations you do, the better it gets. So you spend less time doing these kind of manual tweaks, but you can see it's doing a pretty darn good job. It got the invoice total, the currency, and I think we're just going to skip the items for now. We'll fetch this taxable amount out. And then of course, if we need to make any manual changes, like click into the field and manipulate that a little bit, we can do that. We'll go ahead and say the rest of these fields are missing, and we're going to process this. And now what's going to happen once we click save is it's going to kick off a robot automatically. So this is tying these two together. You can see that job running right now. It's going to kick off our next robot. It's going to open up our new system. It's going to submit our invoice with all the fields we just entered. Awesome. So now that that's been submitted, let's go ahead and check and make sure the system received it. And again, this can be stored in any backend system. The power of RPA lets us connect to practically anything. Awesome. So you can see it's all in there. And so next up, we're going to do the second invoice. And this one looks different, right? And this is kind of that first kind of scenario we're really showing around, hey, what happens when we have the same invoice or the same document that's kind of differing formats? How do we handle that? Right? So this one was close. It got manufacturing, but it missed growth mark. That's okay. Got the date. We're going to bring in those exception details. Got the date, which is good. It got the invoice number this time, which is also good. And the PO number it still needs some help with, but that's fine. But you can see how easy it is to map this. Much less time than actually manually keying this in. So we'll go ahead and mark the rest of the stuff as missing. But it got the invoice total right. The USD currency is correct. And again, it just detects that looking at the document, it sees the dollar signs and says, hey, it's USD, which is pretty cool. So go ahead and mark, I think, the taxable amount here, and we'll put in the 6% tax rate because we want to capture that. And then mark the rest as missing and go ahead and save. And again, this is going to kick off that exact same job. It's going to open up that form, process the data for us automatically. How easy was that? Pretty cool. And of course, if the input fields require drop downs or things like that, we can of course accommodate that. This is kind of more of a piecemeal example just to kind of convey the concept. Great. So both of those invoices have been submitted successfully into the system. Awesome. So like the earlier demo, we're using three main components here: RPA, document understanding, and Action Center. If we pay our invoices faster, we can get, on the good folks list and potentially realize better discounts, right? More importantly, we reduce the total cost for us to process each invoice, which is it's going to be a tremendous ROI over time. Should really keep track of how many invoices need rework and continuously work to push that number higher. Something Zach and I are going to talk about later is really about improving these models. When they show up on day one, they're definitely feasible. They definitely do quite a bit of work, but it's the training and the iteration that makes them amazing. So just something to keep in mind there. And lastly, since we have a little bit of time here, I just wanted to show you how other industries might use document understanding, because it can be super cool just to see how businesses outside of our own can use these tools. And so let's say we have a recruiting business and we're paying to get resumes from some of the big job finder websites. And what we want to do is we want to extract recent job titles from each resume and proactively reach out to that specific company to see if they need help backfilling the position. So you can imagine that's a very difficult ask. I can almost see Zach over there moving in his seat. There's literally millions of resume formats to train. I mean, we can all go and create our own resume formats. So that's a huge challenge. So how do we do it? We cheat. We intake 5 resumes here, and I'm going to show this, show how it works. But it's actually really cool, and I'll clarify the cheating that I did later. All right, so in this case, we're running our robot to extract these 5 invoices. It's going to go through each one of these 5 completely different invoices and extract all the jobs that they've worked at.
Resumes, Dave.
Oh, sorry. Yeah, resumes. I appreciate that, Zach. Yeah, all the resumes. I've been doing too many AP AR demos over the last month. No, that's fine. So we're going to extract the resumes here, and you're going to see it takes about 15 seconds or so to process these. Sorry, the video's taking a little bit of time to catch up here. But it may seem slow when you watch it like this. It's actually really fast, because if you think about it, it's processing one of these every 25 to 30 seconds. And if you compare that to how long it would take to open that up and key that information in, and remember, a lot of these are PDFs. You can't even copy paste sometimes from these PDFs into other documents. So definitely something to think about there. So we're processing our final invoice here, and then we're going to process our final resume here, and then we're going to get into how well it actually did. Awesome. So this is a single spreadsheet, and now we're seeing we've got our 3 resumes on the left here, or on the right, which is the consistent resumes. These are the ones where all the fields have been extracted correctly, right? And so everything, the headline, the employer name, the period of time, the position, we found a match on everything, which is super cool, including the location as well, which is also nice. So we're just going through here and just kind of showing you the matching across all of these. So let's close out of that one and go look at the next person. You can see completely different invoice, but it still captured the data and it structured it out. I mean, I keep saying invoice. Oh my gosh, I'm so sorry. It captures all this information from the resume. I'm never going to hear the end of this from Zach. But anyway, we're going through and we're processing all of this and structuring it all out, which is really cool. All right, and we're going to look at one more here. Awesome. You can see completely different. Just as a technologist, this is so cool, just like for me to see. Like, I can only imagine like what it does for folks that are inside these different business groups. You know, the ones that are really spending all the time having to do this manually. Awesome. So it looks like it came over really well.
Yeah, and one other thing too, David, if you don't mind me adding here.
Yeah, of course.
One thing that we can do that's really helpful here is we can use machine learning algorithms to actually go through these resumes and pick out the best keywords that would fit a candidate, right? So if we have an open position and there are certain keywords that we want to look in a resume for to help identify, you know, out of 100 resumes, who has the most keywords and therefore may be the best candidates for these positions, we can use machine learning to go ahead and do that automatically. So you don't have to have a recruiter or someone from HR go through 100 different resumes. You can actually run this machine learning model using RPA and ML, and we can actually spit out, you know, the top 10 or 15 or 20 or however many you want of those resumes that match those keywords. So there's a lot of really cool stuff that we can do with that.
Awesome. Thanks, Zach. Appreciate that. So in here, we're looking at some inconsistent resumes. So for these ones, there was at least one field that didn't make the cut. But you can see it still did a pretty darn good job getting the information out. It just missed some locations. That might be because the location wasn't even in the resume. And so you can see that. I think we're going to compare it here on the left. There's going to be examples, like for example, the September 21 SI 2015 to present. I believe it was actually typed like that in the resume itself. And then, or no, that's over here. Yeah, we're looking at this one now. But you can see some of these resumes. I mean, I don't know if I would submit this resume, but you can see just how varying they are. and what it's able to capture. And in this case, it got a little confused on that period, right? Because it's put 2014 to first, but that's actually in the resume. So it's bringing it in, but it's also like, huh? I'm not really sure. And so it's really cool to see the intelligence kind of work like this to do its best. And any sort of human processing that we can take off the plate is going to result in a lot of time savings and a lot of money saved. So
especially when you're looking through 4-page resumes, right?
Yeah. So naturally, I know I'm going to get asked, so how did you do that? And I said I cheated earlier. And the reason that I say that is because UiPath provides some really powerful document understanding capabilities, and we certainly default to using those. But it's really, really good for you to know that in the event that we kind of go above what the stock document understanding engine can do, there are companies out there that their whole product is a machine learning algorithm that we can call into very easily using UiPath's RPA platform. And so what we did here is we still launched it using a UiPath robot, but we connected to an independent third-party machine learning algorithm trained on millions of resumes. And so that's how we were able to get such good results. Now, it's important. An important consideration here is that when you use a premium model like this, it can be more expensive. But something to think about is, well, why not take a crack at it with document understanding? And if the confidence isn't high enough, then you call NanoNets versus just calling NanoNets every time. This is areas where you can start to get some really, really cool solution architecture going, solving problems, saving money. It's what automation's all about. So that's the demo for today. I hope you guys enjoyed it. Thanks for watching. And does anyone have any questions that either Zach or I can help address?
And Kramer, how do you think about quantifying the ROI when you're looking at these opportunities? I mean, this is a kind of going outside of just looking at the technology, but I mean, we're partners here. I'm just curious, like, what are some of the key things you look for in these kind of solution situations?
Yeah, I know one of the main measures that I've seen is actually the cost internally for you to process an invoice. Like, you can start to measure some of this stuff out based off, what people are being paid in those roles and kind of how many invoices you're dealing with and how long those folks are working, or whether or not you're having to put in overtime to get some of this stuff done. You can start to kind of identify what your initial cost is. And then from there, you can start to break down and say, okay, well, by applying the technology, every additional component that we add gets us 5, 10, 15% faster, which makes us save X amount of hours, which saves X amount of money. So there's also some really good insights that we have within our group to look at specific processes and then tell you the different measures that you might need. Zach, I don't know if you've had any come up on your end. I know you've been a little bit more involved on client projects than I have.
Yeah, I mean, you nailed it. The cost per invoice or per document processing is exactly what we look at. And again, those factors that kind of go into that are how much you're paying those, the FTEs that are doing those, how long it takes to process those documents, and then what the efficiency is on that as well. Because, a lot of people, they like to think about the cost per, invoice, for example, but they don't think of the efficiency as well, right? And you're going to have better efficiency with a robot than you would, a human going in there and keying those values in where there could be some mistakes. So it's something, that you definitely need to take into consideration. But, the cost per document processing is certainly what we use as our gold standard.
Awesome.
Right, so that's more like a hard cost. Any soft cost thoughts, like, end user experience, customer experience impacts, rework loops? Those are a lot harder to quantify, but like, I'm just wondering, do you find a lot of customers or prospects looking at those areas too, or?
From what I've seen, the hard ones are like the ones we just talked about. Those are often used to kind of make the initial, we need to purchase this or not decisions. The softer ones, I think, that you're mentioning are almost on kind of, hey, these are the extra little gains that we got out of doing this when we dive deeper into it. And what I would look at there is things like accuracy on the first attempt at processing. That percentage is going to be much lower when you first start versus 6 months in versus a year and a half in, because you've had opportunities to train the algorithm and make it better. So that's something that I can see kind of being more of a softer, but maybe as it goes, it becomes almost a more important one to measure by, because if you can get up to like an 80% success rate on your invoices or your resumes, it'd be pretty awesome, right? And it saves a lot of time there.
Excellent. Well, thank you, David. And Zach, you guys are rock stars. I think we do have a few other questions here, and I'd like to get to them. I have a question. Can you do unsupervised training?
I'm going to let you answer that one, Zach.
Yes, you can do unsupervised training. It's a possibility, I guess, but we don't recommend it. And the reason for not recommending unsupervised training is because the training data that you use is extremely important to the efficiency of your model, right? So you want to have absolute control over what you're feeding your model to train that, right? You don't want to have anything that might contaminate those results or your model, whether that be typos or something else. So we always recommend that, it's a supervised training. But, again, if you get to a point where, you want to do some unsupervised training, it's a possibility. We certainly, recommend that you do it supervised, though.
Excellent. Another question is this available only in the cloud?
Yeah, so this is available both on-prem and in the cloud. We know the businesses are going to need flexibility, right, to choose the path that works based off their internal standards for security and operation. So yeah, definitely over both. There are some hybrid configurations available as well, but we always kind of caution folks to go down that road because it can get super complicated. But it is something we can handle.
So there are choices out there.
Mm-hmm.
Certainly.
And how many languages does Document Understanding support?
So currently there are 62 languages that are supported within Document Understanding. I would love to go ahead and get into each one of those, but I can send that information over to whoever would like that. But lots of different languages supported.
Zach, are you fluent in all 62 languages as a machine learning practitioner? I'm
getting
curious.
there. I'm getting there. Yeah, I might have 59 more to go, but I'm doing pretty well.
Better than me.
You got some work to do, Zach.
I know.
So also, I have another question. What are the most critical elements of success for a document understanding model and deployment?
Do you mind taking that one, Zach?
No, not at all.
Okay.
So the most critical elements I would say are probably having consistency when you're building out that model. So generally, when you train a model, you have to go through and you're labeling this training data. It's extremely important to be accurate there. So a lot of times what will happen is you'll have more than one person kind of going in and helping label these documents to build out that model. And you just want to make sure that they're consistent throughout, right? You don't want to have, the invoice total, for example, labeled in one area by one person and it labeled in another area by another person. There are instances where it's not going to make as big of a difference, but it's certainly our recommendation that you try to have, the same consistency across the board there. So I would say that's number one, right? Number two, I would say is probably making sure that you have quality data, right? And what I mean by quality data is if we're doing an invoices project and we are uploading a data set to our model, we want to make sure that that's all inclusive of what we're actually processing, right? So if we have 100 vendors or 200 vendors or however that many may be, we don't want to have just 10 or 15 invoices from 10 or 15 vendors, right? We want to have, maybe 2 or 3 invoices per vendor in our training data set so that it's all encompassing. And that's very important for when you're building out your ML model. Overall, I would say those are the 2 absolute most critical elements for having a successful DU model.
Excellent. So how can you leverage the pre-built models and make them your own? And are there continuously pre-built models coming out from UiPath?
So the first part of that around the pre-built models. So document understanding models have a good degree of accuracy up front, but over time, they can be trained to be more accurate for the way that you really do business. So it's about iteration. It's about training on low confidence extractions to really improve, the results as you move. Zach, I don't know if you have anything to add on top of that.
Yeah, absolutely. So there are a few different pre-built models for UiPath document understanding that are fantastic out of the box, to be completely honest with you. The invoices model is one of the best coming, out of just a pre-built model, running invoices through and picking up accurate results. There's a receipts model as well, as long as a few others. But the invoices model is probably the hottest one out there that people like to use, and it's very, very accurate right up front, right? Now, if you want to make those your own, right? So let's say for example, maybe you have an invoices and a receipts use case that you want to run through. You can always add your data to those ML models, right? So you have the base package that's out of the box, that's going to work relatively well, with no training. But then what you want to do is you want to periodically add your own data to that. So you want to add, the invoices that you have or the receipts that you have to that to improve that model. And kind of like how Dave was alluding to a little bit earlier, the iterations that you go through make those models more and more accurate the more that you do that, right? So, I mean, those are the ways to kind of use those pre-built models and then to kind of make them your own, if you will.
Yeah, if you want to simplify ML, it's trial and error at a much faster rate.
Yes.
So what impacts your confidence rating?
Yeah, so when we look at the confidence scores that we were pulling out, like in the demos that we had, every field is going to be extracted and compared against the ML model directly. From that model, it is assigned a mathematical confidence score. So the computer and the algorithm attempts to take its best guess. And if we're running into a scenario where it's not, getting the data correctly, then that's a situation where we might say, hey, if we're under like 10 or 15% confidence, we might put that into a queue. Our robot can even put it in a queue. And at the end of the week, we can then train the machine learning model to improve that extraction over time. And as Zach mentioned, we prefer to do that with that training activity with a human, but it is possible to automate it. The automation would probably make more sense for simpler documents than more complex ones.
Excellent answer. And I think we have one more question.
Sure.
What do AI robots do?
I can go ahead and take that one. So an AI robot is basically used to make prediction requests for your ML model. So those confidence ratings that we were talking about, that's kind of where these come into play. And then they're also used to run the training jobs for your ML models. So if you are training a new model or you're retraining a new model, that's done with the AI bots.
All right, well, I think we answered everything. And if there's any additional questions, you can see my email down here at michael.bork@ashlingpartners.com. And I'll be able to answer those questions. And as a call to action, we can schedule some time to discuss your unique document types with a one-on-one call, and we can show you how document understanding will work with the particular document type. All right, again, thank you for your time today, and we look forward to visiting with you in the near future, and we'll have more seminars in the future as well. Thank you, everyone. Have a wonderful rest of your day.
Take care, everyone.
Take care.
Bye.